must be such value of C where f of t equals,
Yeah, good. So it has to be continuous for this to be true. And so we have to say that for sure. This is a good review even though we're not doing it right now. What else do you have to give when you justify these?
the endpoint, or like the y
Values of the endpoints, yeah. You have to give the values of f of a and f of b. And then you have to say that interval thing, like c is between a and b.
C is between a and b, there must be such value.
Yeah.
Or f of c
Good.
equals this.
Yep. So it says that if it's continuous, it takes on every value between there, and so c must produce that value. Good. All right. So that was intermediate value. And then we talked about the average rate of change,
Yes.
which is just a slope, right?
Yes.
So plug in a and b to the function. And then we talked about the mean value theorem, which said what?
That means it's continuous and differentiable then. And the rate of change of an interval is greater than whatever we're looking for, then at some point the derivative is equal to, or that the value we're looking for was at some point the derivative somewhere in that interval.
Yeah. And so we could summarize that by saying the instantaneous rate equals the average rate at something. So make sure you note that's f. Sorry. All right, so we're going to see some of that a little bit in terms of wording. We're going to see that kind of overlap. So average value now, you can see why it's going to get confusing at the end, right? Intermediate value, mean value, average rate, average value. There's a lot of overlap in the wording. So we're talking about the average y value on an interval. So we find that by doing 1 over b minus a. There's our average part. But what's cool is we can take the the integral of the function on that interval. So basically you take the definite integral over the interval. What is it? And then divide it by the difference. Another formula to remember. I have a list of, you might have gotten it last year because I got it from Sid, but a list of things you just have to know. When do you feel like that would be the most helpful to get a copy of? Like now or wait till we're reviewing more?
Probably right when we're finished with it.
Yeah,
Okay.
I would wait till we review.
Okay, so help me remember to do that. Just because then it can be like a study thing, right? A lot of it you already know.
The only thing I forgot was the area of a trapezoid for the trapezoidal sum.
Oh, sure.
And then the summation notation of it.
Oh yeah, that one I don't remember either. It's the trapezoid one. Isn't
The
it?
trapezoid, so area
Or it's
area of a trapezoid
is base 1.
is 1/2 the height times base 1 plus base 2.
Yeah.
Oh,
And in those, let's say it's this shape, the height is the x interval width, I should say. So I don't know if that's on that sheet, but we'll have to try to remember to put it on there. Maybe I'll make a note. I can just add it. And then it was the summation,
Yeah,
the
summation.
definition
Yeah.
of an integral.
Yeah, because it gave us Well, like I knew how to do it if I knew the formula. It
Yeah.
was like asking us what possible b values. I forgot that.
Oh, I remember that one, and it was just like, you just have to remember like F or B and A.
Yeah.
B times A over.
Because it gave us the normal integral with a to b,
Right.
and then it said what is possible b values.
All right, so you remember that
I
part?
remember that.
What goes
And
here?
I had d minus a over n, and then
That's our interval width.
and then f of
I gotta get my F in there. Hold on.
f of something.
F of B minus, or, isn't it F of B minus A?
I'm just looking at it. It's kind of
Fill in the blank.
Fill in the blank. That's what non-calculus students do.
Yeah. Look pretty bad. Yeah, they're probably, it was the way that we said the next interval over, which was,
So isn't it a plus?
yeah. So starting at the lower end, a plus this,
Something.
the interval
A
width
plus, yeah.
times the kth interval.
Yeah, I remember that last part.
Yeah.
But I don't think you really needed the whole thing, you just needed, the problem that I used it on was just, you only needed the B minus A over
Yeah,
N.
but then it had b minus a over n was 2 over n, and then
And it was like A was
like a was like
2,
2.
Oh, okay.
and so B is 0.
Yeah, we did do some of those where you were just trying to find the limits of integration or something. I'm gonna make sure that's on there too. Okay. We've learned a lot of stuff this year, haven't we?
Yeah.
I've heard a lot of stuff this year. Learned is a little bit less.
Yeah.
We definitely talked about a lot of stuff this year.
Yes, we have. All right, so average value. Down below, we're going to see that this becomes, you have to read carefully, but for now, we'll just put this into practice. So we're going to do 1 over 3 minus negative 1. Integral of negative 1 to 3 of 6 minus x squared. Before we do that, if we look at our values, negative 1 and 3, and we're trying to find an average y value between there and there, what would you kind of eyeball it at?
Like 1.5.
What was it?
1.5.
1.5, okay. So let's go do this. This just becomes 1/4. And then 6x. What happens to the, I'm going to ask you specifically, what happens to that?
What do you mean what happens? Like what is it turned into?
Yeah.
It would be
Oh, I need my dx on there. Hold on. Okay, go ahead.
b minus 1/3 x to the 3.
Yeah, I'll write it like you said. It could be x cubed over 3. And then, do you guys remember the notation for the definite integral? Okay. I'm just going to make that in another bracket.
I
Alright.
wasn't sure if that was like an actual thing, and I wrote it on the FRQs, and I wasn't sure if like that's how you're supposed to write it. And I was like, I wonder if I'm gonna get outcomes.
This thing?
Yeah, I did that too.
Well, it's one way. It's not the only way.
Okay.
I think I might have done a line though,
Yeah,
not a bracket.
you can do a line. I always did it as a bracket, but you can do it either way. Alright, anyway, so let's get this over. So 1/4. You know what? Let's just plug this in the calculator actually. Yep.
It's like,
Which we could have done back here, honestly.
oh, that'd be so funny to run in an FRQ.
Or did it calculate?
How were your calculators yesterday?
I found out that you can take the integral of something in the graphing.
Okay.
Like you can
Oh,
graph
yeah.
it and then you click find.
Oh, and it shows the
and you
area
click
under?
Integral and then you can select lower and upper bound and it gives you.
Sweet.
Oh.
I also used the equation solver a couple times.
I just used I plugged my integral into the equation for the graph, and then I found the point.
Okay. Cool. So I guess you have experience. Do you feel like it was better than last year's calculator?
Yeah.
I like that I didn't have to solve. There was this one question where it was like a piecewise function and it has k and it's like for what value of k is this continuous? So I just put it into the calculator, the equation solver, and it solved it.
Sweet. That's great.
You have like a genuine question about the first FRQ though, the calculator one? Letter A?
Which
How
one-
complicated was that?
Which one was it?
The letter A on the first calculator FRQ.
Okay. I'll have to pull it up because I don't remember it. Anyway, so there's our integral. I didn't put the 1/4 in, so I just need to divide this by 4. So 3 1/3. Which you said 1 1/2, right?
Yeah.
So why is it not looking like it doesn't fit with where we saw?
Well, there's also like a bit on the top where it goes even higher.
Yeah. Because technically you're starting from the left side of it and you're going down.
Yeah, and this is negative, right?
Right.
All right. Why don't you grab your calculators, in fact, because I want to show you something I don't know if you knew you could do. So you can, on these no-marks calculators, define a function. So let's say we wanted to do v for velocity.
Okay.
So can you guys tell me, because this is so blurry. Oh, it
V
looks
is
like
the
division.
division
Okay. So do v and then of t, or we'll just do x for now. I forgot to write the function. You have to do the function first. So just pop in front of that and do something like, yeah. I'm going to make something up. 6x squared minus 2x. Okay, and then remember the store button is, I think, x to the y, is that right? Is that the arrow to the right?
Yeah.
Okay,
Yeah.
so shift x to the y, and then hit enter, and it just puts that up there. But it has stored that as a function called v. Now if you want to plug something in, and you want to do v of, you can just type, and remember you can just change the number, like say we want v of 3, and it'll just tell us what that is.
As a whole.
Isn't that cool?
Yeah. Can I do like the integral of that?
G on a good sense.
2 to 5 of v. Can I just put v?
I would do v of x.
Oh.
2 to 5 of
Oh, it does work.
v of x.
That's why.
That is pretty cool. So, a good trick to know if you have to use the same function over and over again, right? Or if you have to want to find different values of it, or define it once and not type it out 60 times. There's various ways. Sorry, I'm having trouble. Junk.
Does that
Alright,
work
when-
you
huh?
go to the calculator?
What?
Does it work when you go to the graph?
The grapher, you put.
Oh, like if you wanted to graph that? Let's try it.
Oh wait, it already has it. It already like automatically put it in there.
Oh, nice. So you just don't have to come back here and redefine a new one. But also, it's nice that it's not, everything isn't like just Y. So you can call it
Yeah.
what you want it to. Yeah, that's very cool. These are nice. Alright, when does the function assume this value? What do you suppose we do there?
Plug it in.
Well, plug it in for what?
You did
Like
under
a
f of x.
Just for f, yeah. So basically we're just solving for where where this is true. Oh, why am I on this cruddy calculator?
What are we, Neanderthal?
Yeah. So
Oh, see, when I
1.52.
said 1.5, I meant x value.
What?
I'm just
Oh,
kidding.
okay. Why are we not doing the negative version?
Because it's not integral.
Right. Okay. So average value, find an integral. We're using the calculator to help, but we could do it by hand, I think, too. And then here's the caution, is when to use that versus the average rate of change version. So what do you think on this first one?
A is average value, and then this average range.
Yeah.
Good. Why don't you go ahead and do those real quick? Okay. So we know that first one, we just do the integral. So I'm defining h with the store feature. And then if we just plug in that zero to 3. Is it on the cosine?
Yeah, H.
Thanks. Okay, and then divide by 3. I could put that in there, in the integral, into the integral. And we'll get 23.5. What are the units of that? Yeah, that's feet, since we're doing, that's the average height. Alright, what's another way you could do that?
Another way we can do it. Like without using a calculator.
Well, we could do that too, right?
What do you
Yeah. What I mean is, what if we did,
Maybe you could take the value at
like find the area under the curve and divide that like how long.
yeah, I guess I'm thinking of this one. So let's do this one next. But I want to show you how we could do what we just did with it as well. Anyway, any questions on that? Everybody's good on that. Okay. And then average rate of change. Did you try doing the h of 3 minus h of 0 on your calculator?
Yeah.
Just to try it? What'd you get?
Negative
97?
7.
Oh, negative 7. Yeah. What are the units of that? Okay. Do you feel like that was time saving to just plug it in and do h of minus h
Well,
of?
especially if it's like an FRQ and it's like using that equation all the time.
Over and over? Yeah.
Like it would have helped with freaking Brandon's equation.
Yeah, Brandon.
Brandon and Chloe.
You hate those names,
Angry.
man? All right, here's another option. So if it's already a rate, or I mean if it's asking about a rate, excuse me, average velocity. What if we turned this into a velocity function, and then we could do the average value of it? Okay, does that make sense?
Oh, yeah. And then that would give us -7, but we would be doing the same process as we wanted.
Oh my gosh,
Yeah.
but we take the derivative of it, and then we're taking the integral of it,
Yeah.
so it's the same thing.
So I'm not sure if it's better.
Well, then you just get to the old thing, because if you're taking the integral of the
Yeah.
derivative, if you're taking the integral of the derivative from 3 to 0, you're going to do h of 3 minus h of 0 over 3.
Yeah.
I feel like that's just more work.
I agree. So it's an interesting concept. So
It's going to be
it's probably
That's
not.
something that I did. Why'd you show me that? Now I'm gonna remember that one. I'm like, wait.
It's not there.
It's like, where did this one go? Is it?
I think I need to take the
I took
derivative.
the derivative and then I plug it into that equation.
Yeah. Let's just forget I ever mentioned it. All right, read this next one. So r of x, where r is the rate at
These two waistline.
this waistline is changing.
Who is Mr. Rowe?
Dr. Depper.
Bucker.
I forgot about that. So what is the average rate of change? What is that going to be?
It's going to be the average rate of change.
It's
It's going to
R of.
Is it average rate of change or average value? I guess is really what I meant.
Average
rate of change.
It's actually
Wait,
average
no, it's
value.
average value because it's a rate.
Because it's already a rate.
Yes.
So if we take the average of a rate, it's the average rate of change, right?
So B is what is the average change of this rate?
Yep.
So it's going to be the average
So
rate.
I know we all relate better to this. So if this is like velocity, this would be like the average. Let me do it as this.
Velocity.
Average rate of change of the velocity. It's the same. So it's okay to just do average value. This would be like the acceleration. So maybe I shouldn't put that. I should put this average value of the velocity. And then acceleration is the average rate of change of the velocity. Probably be a safer way to say it. So it, as we've seen, comes down to reading carefully instead of knowing. It's not just about knowing the calculus, I guess is my point. 10th to the 12th. So what goes in to our integral?
10 to 12.
Yeah.
During the first 5 months. So R5.
I'm not even surprised this is the person who wrote this book. What's the author of the book?
I don't know. Well, I think he's one of the dudes. I don't know if he wrote this stuff specifically, but he's involved. Let's see if he has a picture on here.
Imagine you're making a to believe I just wrote about you.
Yeah. Well, it's one of these guys. I don't know which one.
Oh.
They're caricatures. Just gets right into it.
Oh my, the algebras.
Yeah, it's those guys, I think.
No, I didn't understand the punchline at first.
You're like, what? What is that, man?
Well, I was like, that
They spelled it wrong.
Ew.
That's funny. It's a pretty clever name, I think. Alright, so we can just run this through our calculator. Alright, anybody do it?
No.
Okay.
That's one of the things that I was thinking during the mock. I was like, you guys already know I know how to do this.
I know. Alright, so just don't, you see me doing the division afterwards, just don't forget to do that part. So if you're worried, you could always stick it either out front of your integral or just stick it inside, either one. But what is that, negative 2.682 or 3? And what are the units of that?
Probably inches. Yes.
Not
Inches-
just,
inches per month.
yeah, inches per month.
Dang.
holiday season, how's he losing?
This guy's slimming up.
Inches per month?
That's what I'm saying.
Yeah, if you took almost like
Think
two,
about
two
that.
and a half inches off your belt every month, you have cancer.
There's gotta be something. Well, but then he gains it back. It's a sine function. That means that
That's true. It oscillates.
because,
He's
like,
slimming up for his trip to the beach
at
right now.
some point he's just gonna.
I just don't know how he's losing it. That's
two-
like
that's a
Thanksgiving
whole
time.
pant size. He has to get all new pants.
You're right. You would, but that.
Well, he only has to get like 2 pairs. One for when he's swimming and one for when he's
Nice.